Good morning, everybody. I want to welcome you for our today's webinar about the 1500 volt certified modules. And today we want to speak about the benefits and the challenges. The webinar should take, let's say, about 30 minutes, and then additionally the questions. So if you have questions, please put them in the chat or in the question. And at the end of the presentation, I will check the question part and the chat for question and answering your questions. So today we will start with a short introduction, which will be quite general to give you an overview. Then we will speak about the benefits. After that we will switch to challenges and finally a short summary. What is the background? As you, for example, know from the US, US has already made the second step. So in the past, the US had 600 volts, which was compliant to the UL. Then they switched to the IEC to the 1000 volts, and now they're also switching to the 1500 volts. So what is the advantages, or what are the advantages of increasing the voltage? The one of the advantage, for example, is the increasing of the string length. That means the reduction of the parallel circuits, the reduction of, for example, cables, reduced cable losses, or the enabling new power plant concepts, reducing the number of transformers, and so on. But there are also challenges. For example, there are higher requirement on the module material, which also leads to a slightly cost increase, not only on the module, for example, also on the switchboard, on the inverter, and also for the safety requirements. The complete presentation will be based on the levelized cost of energy. So I want to show you the impact on the different sections. So here we have an overview about how the cost split is for the levelized cost of energy for the LCOE. So we have a balance of system part with a fixed part, for example, with the inverter concept. Then we have the variable one, like cabling, substructure. This is variable, for example, based on the technology. If you're using thin film or if you're using crystalline one, then you will have different variable BOS costs, even if you use different kind of power class. Then for sure you have the module costs, then the part for the financing project, especially in large and utility scale project, and operation maintenance, as called as OPEX, and developing costs, also especially for utility scale, to get the project to life. So today we will mention several points, so mainly the balance of system part, the module part, and the operation maintenance part. As additional point to the LCE, for sure you have the performance, but this is the second level, so because it's the cost divided by the energy you get. So the energy is directly not displayed, but we also mentioned some advantages in terms of performance and where you can increase your energy yield. Now I want to go to the benefits. Here you have an example from the States. They have here compared a 1000 volt system with a 1500 volt system, and they also have built up the cost. They are starting about, let's say, $1.7 per watt, or $1,700 per kilowatt. But if you stay to the $1.7 per watt, then they have an increase for the module with approximately 2 cents in this case, also slightly increase on the inverter side with 1 cent. And then they also have a cost savings. But what is also important is that, for example, the combiner boxes or the monitored combiner boxes connectors are slightly more expensive. But overall, there is a cost reduction due to the reduced number of combiner boxes connectors you will need. And for sure also installation costs like electrician costs. And you can see that overall, with having the additional costs and the cost reductions, you will end up at a system price of $1.68 per watt, what gives you a saving of 2 cents per watt. If you now go to a European example, here you can see what will be impacted. So basically the impact will be on the fixed BS part, variable BS part, and the module part. Here we have an example of two framed modules. So here we have a 1000 volt module, so what is certified up to 1000 volt, and another one what is certified up to 1500 volts. If you make now the comparison though, or it's already considered that the module costs are here in this case approximately 1 cent higher. The substructure costs and the installation costs for substructure modules are the same. The main difference here is in the electrical BOS part. Though in the electrical components, in the cost for the electrical installation like cabling, making the interconnections between the modules and stuff like this. And here you can see that the increase from 1000 to 1500 volt leads to a cost reduction of approximately 33%. So if you compare this on a complete system level, then in this example we have a cost reduction of 4.3 euro cents or 4.5%. If you now take a look here on the LCE, and if you have, for example, location, let's say in the south part of Germany or in London, where we have, let's say, an energy yield between, let's say, 1000, or between London it's more in the direction of 950, or if you go to South Europe then 1200, but if you now stay to 1000 kilowatt hours per kilowatt peak, then we will have an LCE of approximately 10 cents with the 1000 volt system. If you now change to a 1500 volt system, there will be a drop of approximately 4.5 cents, which leads to a totally LCE reduction of 4.9%. That means that the profit of the project is higher, and the investor will for sure like it because he have at the end more money in his pocket. If you now take a second example with the framed module, so it's the same like before, but now we have a frameless modules, because there are several framed and frameless options in the market, and for example also we offering 1500 volt modules as framed and frameless version. The frameless version has, for example, the advantage of a reduced degradation, what I will show later, and on the other hand it has slightly higher cost, but I want to show you or give you a complete overview. Though in this example the module is slightly more expensive than before, so we have total costs from 0.933 cents, and the new for the 1500 volt system for the frameless will be 0.911. The major difference between the systems are the module. Here we have the frameless, and also here, as you can see, the BOS, the substructure costs, so the mechanical BOS costs are slightly more expensive. Though in this comparison it's assumed that for the frameless module you need to invest 5% more money for the substructure due to the different kind of clamps, due to a little bit more effort for the installation. But as you could see, also the electrical BOS, it's the same like before, so there we have a reduction of 33%. If you now take a look again on the LCE, then we have again for the standard 1000 volt system, for the framed one, 10 cents. If you go to the 1500 volt with the same operation maintenance for the framed one, then we are on the same level like before, because we have a lower degradation. So the additional investment gets, or the additional investment gets overruled or gets completely equalized by the additional energy yield due to the lower degradation. But if you also take into account that for glass we have a lower reduced operation maintenance effort. Why we have a lower reduced operation maintenance effort? You know that we have a mechanical stress on the module, so the module will deflect due to the wind loads, due to snow loads. And if you now compare the dual designs, on the one hand we have a frame module, which is basically a glass, and we have the cells and the foil on the back side. The glass is symmetric, so the cells are in the middle. If you have now a deflection on the module, then with the framed one, the cells have will be treated on a higher stress level. They have higher applied force because the cells are not in the neutral phase. The neutral phase is close to or is in the middle of the module. That means the risk of having micro cracks with the framed modules over the project lifetime is higher, compared to a frameless module where we have the same glass thickness for the front and the back glass. That means the mechanical stress on the cell is much reduced because it's in the neutral phase. Though I assumed that we have a lower module exchange rate due to less micro cracks, and then you can see that with a frameless system you can achieve lower LCU than with a 1500 watt frame system, and there you can see that the LCU reduction will be, let's say, increased from -4.9 to -5.1%. So with a frameless module you can achieve higher LCU reduction than with a framed 1500 watt module. If you now take a look on the performance, because you already may read in the magazines or in some reports that it will be assumed that for the inverters there will be a high efficiency. In the example I have here, the efficiency is the same, but it is expected that it's possible with 1500 volt to achieve higher efficiencies or higher efficiency on the system level with the conversion. That means, for example, lower losses in the transformer because we can operate with a higher input voltage. But where we for sure have a better, let's say, better performance or performance increase or loss decrease is on the cabling. As you can see here, the string cable and the home run cables, the cable loss will drop. So you can then decide to have lower cable losses, though better performance, or lower losses, or you can say, okay, depending on the acceptable cable losses, I go with a smaller cable, so with a lower cross section, to save on the capex side. But this shows that with a 1500 volt system, it's also possible to achieve a higher performance than with a 1000 volt system due to the reduced losses and the increased efficiencies. If you now take a look on the operation maintenance, so we are now impacting the operation, the OPEX costs. If we make a comparison, though here we have a 1000 volt system and a 1500 volt system. This is based currently, let's say, on an example from SMA. There we have for a 1000 volt system, they have an inverter station. Inverter station is a package with inverter, transformer and substation. They offer it with the size of 2 megawatt. For the 1.5, also for the 1500 volt system, it will be 2.5 megawatt. So the number for 10 megawatt project gets reduced from 5 to 4. The same applies to the combiner boxes. Due to the longer strings, the number of combiner boxes is reduced from 76 down to 50. For sure, the number of modules is the same with 31,250 because they have the same power rating. If you see there, that means we have a less number of components to check at a 1500 volt system, and this means we have a reduced effort for frequently inspections like module inspections, cleaning, let's say inverter cleaning, for example, also cleaning or checking inspection of the combiner box. Remaining parts like the cleaning of the module inspection, this will be for sure the same, but the reduction of the components you have to check on the inverter side and combiner box will lead to an OPEX saving of approximately 4% compared to a 1000 volt system. So also the higher voltage enables savings on the operation and maintenance side. I already hit the point that the DuoMax, the glass module, has a different warranty. So you can see here that our conventional module has a warranty of, or a warranty degradation of 0.7% per year. With the glass, this is reduced down to 0.5%. That means over the lifetime, the energy production with the DuoMax will be higher. That means even with a higher product price, if you have a system price of approximately 93 euro cent as example for utility scale project, then we will have an increase of the profit or reduction of the LCE of 5.1% due to the due to the higher performance, due to the lower operation maintenance cost, and so on. This shows also that a glass module, especially for higher voltages, is a perfect choice. Now let's take a look on power plant concept, because this will be also discussed, or is also discussed in the industry, because you can go steps further and you can also introduce new concepts which can also impacting your costs. In this case, the power plant concept will mainly impact the fixed balance of system costs. Here in this example it's shown the impact on the output voltage, which is the input voltage of the transformer. The transformer here in this case will step up will step up to 20 kilovolt. In the first example with a 1000 volt system, we have a step up from 360 volt to 20,000 volts. With the 1500, this can be the input voltage, or the output voltage of the inverter can be increased to 570. And if you go with new concept like, for example, bipolar, then what is currently under research, then the output voltage can be increased of the inverter of up to 1000 volts. And if you now take a look on the transformer, transformers are usually limited by the maximum current. In this example, it's 6,500 amperes. For sure, this depends on the manufacturer. Though, if you take the 6,500 amperes and checking now the different cases, so in case A, the maximum transformer size will be 2.3 megavolt ampere. In the case B with the 1500 volt system, it will be already the size 3.7 megavolt ampere. That means you need less transformers per project. In the case C and D, where we have a much higher output voltage, there the transformer size can be up to 6.5 megawatt ampere. If you now take only look on case A and B and compare them, so in the case A, and assuming that we have a 50 megawatt project, we will need 22 transformers. In the case B with the 1500 volt system, only 14. That means the installation effort for the transformer, which is, let's say, per piece approximately the same, even if they have a different capacity. So the installation effort can be reduced up to 36% based on these numbers, which means also your fixed BRS, your capex, will be reduced. That shows that also the 1500 volt system enables for new power plant concepts, which leads to further cost reductions. But beside the benefits, for sure, we also have challenges. One of the challenges is the availability. As you could see here on from the module side, there are already a lot of players delivering and having available 1500 volt products. So for example, for Trina Solar, we have all our glass modules are certified to up to 1500 volts, and also we will introduce soon, or they already introduced, framed 1500 volts in different dimension and different cell technologies. For connectors, it also looks quite good. The same for, let's say, junction boxes, what is attached to the module. Then for the cabling as well, if you're going to combiner boxes and stuff like this, then it will, the select or the number of choices you can have is already reduced, especially also if you look for monitored combiner boxes, which are needed to check how your system performs. The same applies for inverters. But there the number will for sure increase, because for a lot of inverter manufacturers, they are under developing or have already started production, also have some already have built the first projects. Due to the limited availability, there's also the scaling effect. So it can be also expected that in the future with the scaling, the cost of combiner boxes, inverters will also drop, and let's say be similar like for 1000 volt system. If you now take a look on another picture, what is from GTM, from Green Tech Media, here you can see the availability modules are marked here in red, I would say it's more in the direction of green, because we already have also installed a lot of, for example, glass modules around the world. For inverters, I would say yes, depending on the inverter what you're looking for. For central inverters, it's better than for string inverters. And I also want to show here the impact on the monitoring system. Because you know, with increased string lengths, we also have more modules per string. What is leading finally that the monitoring system needs to be more accurate. So if you take here the example, that we have here a 1000 volt system with a string length of 19 modules. That means if one module is defect and get bypassed by the bypass diode, then we have finally 94.7% of the maximum voltage, so of the 703. If you take now a look on the 1500 volt system, there we have a string length of 29 modules, and if you have there one defect module which get bypassed, then the ratio to the let's say maximum voltage with 29 is 96.6. That means you can see that the impact if we have voltage drops on the 1500 volt system are lower. This leads to the requirement that the monitoring system needs to be more accurate to see the differences and to show you where you have to go and check, for example, connections, or if a module is broken, or if you have too much soiling on the system, especially if you speak about soiling. So if you have a lot of dust on the modules, this will also lead to a voltage drop. And if you want to align your maintenance, or you make your maintenance based on the monitoring system, that means your monitoring system says, I have too low voltage, so it's time to clean. Then for this kind of operational work and maintenance work, it's required to have a more accurate monitoring system for the 1500 volt system. Even if you have the monitoring system, it also shows that if you have defect components in the system with a 1500 volt system, it has a high, let's say, higher impact. That means it's required for 1500 volt system that the quality of the component is on a high level to have the performance you expect from the power plant. Now we take a look on the potential induced degradation. So potential induced degradation, it's basically electrical field what is caused between the potential difference from the active cell and the grounded framed. So it's a potential difference between the cells operating on the system or operating on the VMPP and the grounded cell. So this leads to some diffusion effects and leads to a degradation. So if you have a conventional module without any PID, then the impact can be quite hard, especially in tropical climates, or if you're close to sea or lake, so in salty air, for example. With the framed module and the PID resistance cells, you can see that the PID effect is already reduced, but with the Duo Max, it's further reduced, so with the glass. And you see, or what you also can expect, because it's a potential difference, is that with an increase of the system voltage, that means the potential difference between the cell and the frame gets increased. That also the impact, the degradation effect, can be higher on the modules, which means a glass module has their advantages. On the next slide, I want to show the differences and the advantage of having a glass module as for higher voltages. As already explained, it's a potential difference, so there will be diffusion process in the module which leads to degradation of the cell. And here we have a potential difference between the cell and the frame. For a frameless module, first we have a glass on the backside. A glass on the backside is always a bigger resistance against the environment. Then we have our EPDM, or rubber, to protect the glass laminate from the clamp. So it's an additional isolator between the glass surface, and also a bigger isolator between the glass surface and the clamp. And because the clamp is only on a small location, on a small area on the module, That means even if we have their electrical feed, it will be always, the impact will be always smaller than on a friend, because on a friend module, because the frame is going around the complete module. And so you have more like an inducing loop, because friend is electrical connected together. That means having electrical fields on a friend modules which can impact the cells, the risk of having it is higher than on a frameless module. Additionally, for frameless modules, there are further options to install the modules, like for example with some kind of hooks, which are small rails bonded on the backside, or let's say back rails, which are also bonded on the backside. That means if we have here no clamp, then we will have here the adhesive and then the clamp below. That means the distance from the active cell and the next conductive component will be increased, and the increased distance from the active area to the next grounded part will lead to a lower effect of PID. At least I want to give you a summary about the points we already discussed. First, we have some benefits. Those benefits are for sure the reduction of the electrical components due to the longer strings, which approximately 33%. Then the higher system voltage also enables new power plant concepts. That means larger transformers, less number of transformers, high output voltages of the inverters and stuff like this. And for sure reduced operation maintenance, because you don't have to maintain so much inverters. On the other hand, the challenges are especially the availability, especially for 1000 volt, 500 volt inverters. For central it looks better than for strings. So for strings the number of inverters are now available on the market is limited. The increased risk of PID due to the higher voltage. Also the limited experience in installing 1500 volt system, what for sure will come with the future, and it will go very fast because it's quite comparable to a 1500 volt system. A challenge for sure will be the accuracy for the monitoring system to identify malfunctions, voltage difference. Another point is the module mismatch, because the string is longer. A longer string means that a higher number of modules will be impacted by the module with the lowest current. As you know, a string will be limited by the lowest current, or the module with the lowest current in the string. That means with the 1500 modules, more modules are impacted by the mismatch because the string is longer. This means with the PID, with the higher, also with the bigger block size, because you have bigger inverters, for example, and with the mismatch you require a high quality product. So it's very important for 1500 volt systems that you invest into high quality products to be sure that the system will perform on a good level and also over the project lifetime. Why? You can see here, that's an example for the LCU sensitivity. So if you have here an LC of approximately 9 cents. Here we have the module exchange. So if you're investing into a good product, then you can reduce. But on the other hand, if you have a very cheap product or a low quality product, then you also can increase the LC, what you don't want, because you want to decrease the LC to have higher profit. So if you have a cheap product, you have a high risk of having micro cracks, maybe higher loss due to PID effects, and this leads that over the lifetime your return of invest will go down, the profit will go down. The energy yield, that means what is coming out of the module, what is coming out of the system, because the energy yield, for sure, it's one very important point are the modules, because they are the generator. And the second point is also the proper cable design and the proper inverter selection and the complete proper system design to get the best performance, the best yield out of the system. And the degradation. As I showed it before, for example, the degradation, the glass modules have their advantage. So if we say, okay, we have a default case friend module, then with the better warranty conditions for the glass, we will have better yearly degradation, so lower degradation, which leads to a higher energy production, which leads to an reduced LCOE. Now I want to come back to this pie chart because we already spoke a lot about the different impacts on the different sections. If you now check the impacts, so for example, if you change the power plant concept, then we have an impact here on the fixed balance of system part. It can be, let's say, depending on what kind of concept you use, can be, let's say, between 0 because it's equally to the 1000 volt system, but it can be also, for example, 5% by having a reduced number of transformers. For sure, what you have in any case is the reduction on the variable BOS cost, because in the variable BOS cost it includes the electrical components like combiner boxes, connectors. Where you have with a 1500 volt system a lower number. So here you can expect a relative reduction of 9 to 10%, 10.5%. If you have now the module will be a little bit more expensive, so here you will have a relative increase between 2 and 5%. And on the other side, you have reduced operation maintenance, for example, especially, first of all, due to the reduced number of combiner boxes, also inverters, and you can also have lower maintenance costs due to lower number of module exchanges. And here the impact is 4 to 5%. For example, to show you also what products Trino is offering. Trino is offering a friend module. It's always with an E in the middle, so behind the P for poly or D for mono. That means we are offering, for example, the Talmax for utility, also for large and utility scale projects. They are having certificate for 1500 volt for IC and UL, so they can be used worldwide. This will be also offered soon as a 60 cell version in polycrystalline, and we also extend it to our monocrystalline products in 60 and 72 cell. On the other side, we have the Duomax module, that's the glass module, and there all our products already come with the 1500 volt certificate for IC and UL, that's the same, and this is available as polycrystalline, monocrystalline with 60 and 72 cell. I will now, though thank you very much, I will now check for questions, answering the questions. Here's one question, it's a little bit longer. One question was regarding the cost, and I guess I mentioned it later, because the question is that due to the higher requirement on the isolation, there's a high isolation level, this will have an increased cost on the inverters and the module. So it will be on, for the inverters, the discussions I had so far with inverter manufacturers, that it's not pretty sure how much the increase will be, especially if we have a similar scaling like with the 1000 volt inverters, because some of the for sure there will be high effort for the isolation, will be additional cost, but there can be also some cost savings to the higher voltage because there's lower stress on the components due to the reduced current. So there, this is not clear. On the module level, for modules it's quite clear we need better material for the better isolation, which leads to additional costs. The question is, will the presentation be sent? Yes, we will send it after the webinar, and you will receive the presentation, and we will also publish the recording. There's a question about shading on the same, so there I need to say it clearly depends on the model orientation, what the shading will be. For example, if you mount the module in landscape, then you only impact one substring, and if you install them vertical, so portrait, then you will impact the complete module. But the impact will be quite similar because it's basically the same mechanical layout. Yes, the Tallmax is this frame, and the DuoMax, the Duo is for two, is for two glass sheets. There's the DuoMax, two glass sheets, and Tallmax this frame. There's a question about self-cleaning. So the minimum inclination should be 10 degrees. For framed, maybe a little bit more, but let's say in Europe or in most parts of Europe with 10 to 15 degrees you will already have a quite good self-cleaning effect. There's a question about what are the benefits using 1500 volt string inverters in project lower than 5 megawatt. This clearly depends on the availability and also on the output conditions. So this needs to be, though there can be advantages, but this needs to be defined on the case. So it's really hard to give there a general statement on it, because it always depends on the project and on the system design you want to choose, and for example what kind of central system you will compare to with the decentral system. There's a question, what will be the big benefit on smaller plant sizes between 0.5 to 1 megawatt? So there the benefits will be clearly to have a reduced number of electrical components. Maybe with the power plant concept, what I showed with a higher output voltage, maybe this benefit cannot be transferred, but the benefits on the electrical components can be transferred. And so this is the main point. And for sure also the operation maintenance. That means the maintenance that you need to check, for example, combiner boxes, stuff like this. There's a question about the safety and how to manage with a higher voltage level. For sure the requirements may increase, but especially for utility scale project it's always required to have a fence around, because it can be always that there's a potential difference, let's say, between the substructure and maybe you, as in this case if you touch the operating module, you as conductor. However, for the quality for the module, so the module will be tested on the standards. That means there will be also perform all the safety standards, and one of the most important is, for example, the wet leakage test, where you put the module in water and then applying voltage on, so that you can measure the leakage current. What does it mean? If you want to certify a module on 1500 volt, for sure the test will be done for 1500 volt. That means also the requirements on the safety for the 1500 volt modules are higher than for 1000 volt module. And for the rest, for the remaining part of the power plant, for sure there should be the same or even a little bit higher safety standards applied than for 1000 volt system. But there's also already some experience in the market, because you know, for example, parts of the railway industry are working with 1500 volts, and also in certain countries there's a so-called low voltage directive, and this low voltage directive is going up to 1500 volts. This is already covered in the general electrical standards. There's a question about how it will look like in countries with a low labor cost. Especially the savings on the labor will be smaller for sure, though the difference will be smaller, but you will save anyhow the component costs, and then it's part of risk management how the inflation of the labor cost will go on in the next years. And forward looking, it makes also sense in countries with low labor cost to investing into 1500 volts to be sure that also the operation maintenance cost will be on a low level in the future. There's a question if our glass models can be used on single axis trackers, and there we are working on though. Please feel free to contact us, though my email address is in the presentation, and then we will give you some more details about it. There's a question about grid switching issues and there I would say that's more a general point, and because that's let's say more after the transformer and more in direction of the substation. Though depending there, I would say in these conditions, clearly depending on the system design and clearly depending on the project, it cannot be directly answered because it depends on the local conditions. And then, depending on the local conditions, then you can select, let's say, operation method and controlling methods that you can maybe step up the power plant and not having a full switch on. There's a question about module quality from Trina and against competitors. The quality, Trina have a vertically integrated concept for the module production. That means we know the quality from the raw material until the final product. We have 47 inspection points. We do a flash test and AL test on every module, so we know exactly what is coming out of the line. And we also have a key state lab. The key state lab is it's a high quality lab, what can be compared, let's say, with Fraunhofer ISE or the TÜV Rheinland. So we also know before we send our modules to certification that we know what will happen with the product and that we will pass the test. And other competitors may don't have all this implemented in the lines, but we have. There's a question why going to glass, why not bifacial? There it's, I would say it clearly depends on where do you want to install the system, if bifacial really makes sense, because you need a certain minimum reflection from your surface to have additional benefits with bifacial technologies. But yes, it's we are working on. Okay, that were all questions. Those, thank you very much again for your attention, and we will send the presentation and the link to the recording after the webinar in the next days. Thank you very much. Have a nice day.